Okay. So a few years ago, guys learned exponent laws. And there were three main types of exponents. When I multiply two powers that have the same basis, I can write it as a single power. And what do I do with the exponents? If I divide two exponents, sorry, two powers with the same basis, I subtract these. And finally, if I take a power and raise it to another power, that's the same as the base multiplying exponents. So there are three primary exponent laws. And since exponents and logs are related, there's actually three log laws that are very similar to this. Okay? Like this one we call the product law for exponents because we're multiplying two powers, which means we add the bases. This one we call the quotient or division exponent law because we're dividing two powers. And this one we call the power to a power because we're raising one power to another one. The names for the exponent laws, the log laws, are very similar. So here's the exponent laws. Here are the log laws. So when I take the log base something, whatever that is, of two expressions being multiplied, that's the same as taking the log of the first expression plus the log of the second expression. So for example, if we had this, and it works the other way around, so we can go here and we can go backwards. So in this one, you're given it in this form. Well, this can be written the same way as this. So we can combine this into a single log. Log base 6 of these two numbers multiplied, which is the same as log base 6 of 36, which you can actually do. And remember how to think of it like exponents. 6 to the what is 36? 2. So the log base 6 of 36 is 2. If we take the log of two expressions being divided, that's the same as taking the log of the first expression minus the log of the second expression. Or again, the other way around. So in this example, we're given it written out in two logs. We can combine it into one log. If it's subtraction, we combine it into a division. If it's addition, we combine it into a multiplication. So this is the same as log base 2 of 48 divide 3, which is the same as log base 2 of 16, which is what? Again, right, you're asking yourself 2 to the what is 16? Try that again. And this one, the final one, if I take the log of some expression raised to an exponent, that's the same as multiplying this exponent by the log. Okay, so really what I'm doing here is to change from log of an exponent, I just take the n and put it in front, and it becomes multiplication. So for example, this one here, it's written in this form. I want to convert it to this form. So I take the exponent from the argument and drop it in front. This means the same as 5 times log base 7 of 49. Well, I can do this. What is the log base 7 of 49? 2. Because 7 squared is 49, and therefore 5 times 2 is 10. You will always get these. These are on your formula sheet. You do not have to remember them. Okay? So what we can do with these things is we can do questions where you're given a log, a single log, and you're asked to expand it out. Or you're given expanded log and you're asked to compress it into a single log. And you use the log laws to do that. So here, in these examples, we're given the expanded form. And we need to compress this into a single log. Well, first of all, what you should do is look at the ones where there's numbers in front. So this one. How do I write this as an exponent? Like, how do I change this to an exponent? Where do I put it? I put it with the x, right? According to this log law. So this is the same as log base 9 of x squared plus log base 9 of y minus log base 9 of z. So now I've got nothing in front of the logs. Now I could use the other two laws. If I combine these into a single log, because it's addition, doesn't this become multiplication? And then if I subtract, doesn't this become division? So I'm going to multiply these two and divide that. So to express it as a single log, well, these two become x squared times y. And because this is minus, it becomes divide z. Just like that. Or you can think of it like this way. If it's plus, this is going to be in the numerator. This is going to be in the numerator. Because this is minus, it's going to be in the denominator. Okay? That's another way you can look at it. For B, deal with the numbers in front first. So the first thing I got to do, take those and put them in exponent form. So it becomes log base 3 a to the 1/2 minus log base 3 of b to the 3rd. How do I write that as a single log? Division. So log base 3, notice, just like with exponent laws, the base stays the same. So we can only combine them if all the bases are the same. So it becomes a to the 1/2 divide b to the 3rd. Or sometimes what you may see, what's another way to say a to the 1/2? Square root. So you may see it like this, square root a over b to the 3rd. I would accept this. Okay, this next one. Well, look for any numbers in front and make them exponents using the power law of. So I got to drop that in there. I got to drop that there. I got to drop that there. That's the first step. So 2 log W becomes log W squared. Nothing in front of the second one to make an exponent, so just minus log x, same thing. Minus log y, and that 1/3 becomes the exponent. Plus log z to the 1/2. And I've taken care of all the exponents, or all the numbers in. Now I need to write as a single log. Well, remember, this is positive, so it's going to be in the numerator. This is negative, so it's going to be in the denominator. This is negative, so it's going to be in the denominator. And this is positive, so it's going to be in the numerator. So to write as a single one, it's going to be W squared times the other one in the numerator, Z to the 1/2. Divide, and then the ones in the denominator. I've got X times Y to the 1/3. And you've written it as a single. For D, very similar. Okay? Except you are asked to state restrictions on the variable. Remember, these are called the arguments. These numbers here, right now they're variables, but if I replace them with numbers, it always has to be greater than 0. You cannot take the log of 0. You cannot take the log of negative numbers. They have to be positive. So the restriction would be X must be greater than 0 for me to use this expression. Well, this looks pretty straightforward. What would this look like as a single log? X squared times X, which is X to the 3rd, or X cubed. Because remember, this is the same as X to the 1st. So that's when we have expanded form and we're writing it as a single log. Remember, we can go the other way. Questions like these, where you have a single log and you got to write it out, expand it out. Well, when I take the log of 2 expressions being divided, that's the same as subtracting, taking the log of each one and subtracting. So log base 5 of A minus log base 5 of B to the 4. But now I got to deal with that 4 exponent. Remember, to change that, we just drop it in front. So our final expanded answer is going to be log base 5 of A minus 4 times log base 5 of B. We're just going in reverse order to the previous questions we did. For the second one, I'm going to have 3 logs. I'm going to have log base A of X. And then what with the Y? Plus or minus? Plus. Log base A of root y, and then plus or minus log base a of z squared. Take any exponents and drop them in front. Remember, this one is an exponent. Root y means the same as y to the 1/2. So that means you got to take that half and drop it in front. And here you got to take the 2 and drop it in front. So our final expanded answer is log base a of x plus 1/2 log base a of y minus 2 times log base a of z. Okay. And the final one. How many logs am I going to write? 4? 10? Like when I expand it out, how many am I going to write? 4? 3. Because remember, this has got parentheses around it. This is treated as a single expression. So we've got 1, 2, 3. So it's going to be log base 10, obviously. Yeah, I know what you meant. Yeah. Of w to the third. And then plus log x. And then minus log y minus 1. And how do I make sure that that y minus 1 stays together? Parentheses. Do I have any exponents to change? Yes. The first one, I got to drop it in front. So I get 3 log w plus log x minus log 2b in parentheses y minus 1. Remember, you need parentheses. Okay. So here, these are ones we can actually evaluate. They're not variables, they're all numbers. Notice they're all written out in expanded form. So we got to put them as a single log and then evaluate. How would I write this as a single log? Log base 4 of 64, multiply the 2. 32 times 2. And now evaluate it. 4 to the what is 64? 3. How would you write this as a single log? Log base 3 of the quotient of these two, 90 divided by 10 is 9. Okay. I'll just show you where we got those from. And what is log base 3 of 9? 2. That's 3 squared, or 3 to the second is 9. How would you write this as a single log? What would you have to do with all the numbers? What would you have to do with these two? Multiply and then divide. So it's going to be 4 times 5 divide 2, which gives us log 10. And remember, if there's no base, it's always assumed to be 10. So 10 to the what is 10? 1. This one, we've got numbers in front. So we have to put these as exponents first. So this is going to be log base 6 of 12 squared minus log base 6 of 16 to the 1/2. Well, what is 12 squared? 144. What is 16 to the 1/2? Remember, this is the same as square root. So square root 16 is 4. Now I can go further, write a single log by doing what's the numbers? Dividing. 144 divided by 4 is going to give me 36. Two. The 6 to the second is 36. Okay, final thing. All of these logs we've been calculating, you've been able to do mentally. They've worked out nicely, haven't they? Like this has worked out nicely to 2. This has worked out nicely to 1. They all work out nicely to whole numbers or integers. Sometimes it might be negative, the answer. But what if it's something like log base 2 of 17? Well, we can't do that in our head because 2 to the what is 17? Well, I know 2 to the 4th is 16, so it's a little bit higher than 4. So how do we actually do these ones? These ones are going to be decimal answers. Well, we're going to use our calculator for these. And each of you has a button on your calculator, just it says log. And it's always, because it says just log, it's assuming log base 10. To find these ones using a calculator, we can use what's called the change of base. Okay? So we can use this theorem to change logs to a base of 10 so that we can use our calculator to evaluate. And it's pretty straightforward. This here is what this means is I can change this to log 17 divide log 2. You just take the log of the argument, the log of the base, divide them. Okay? And these are base 10, which is what your calculator button is. So now to do this, you have to use your calculator. So if you did log 17 divide log 2 on your calculator, remember we said it should be 4 point something. You should get that. So if you just do log 17 divide log 2, we get 4.087, or approximately 4.1. Which makes sense when we were sort of estimating. So that's when you can't do them mentally, you use what's called the change of base theorem. This you're not given, you have to remember this one. So like these ones here, well, 2 to the 1 is 3. I can't do that mentally. So I have to write it out like this and use my calculator. This one, I can't do mentally. 5 to the something is 785. I don't know, it's going to be a decimal. So I have to take the log of 785 divided by the log of 5. This one, I can't do either of these mentally. I can't combine them because they're different bases. So I got to take each one, write it as a division, do each one on my calculator, and add them. Like so. You should be familiar with how to do these on your calculator. Okay, so if you did this one, you should get approximately 1.58. This one gives you approximately 4.14. This one, if we do the same at the same time on our calculator and combine them, we're going to get 3.30. Finally, this one, we've got numbers. We're asked to write this as a single logarithm, and then we're asked to evaluate it. Well, I can combine all these into a single log because all the bases are the same. So I'm going to get log base 7 of, how am I going to do it? 6 divided by 3 times 2. Or 6 times 2 divide 3. Either one, it's going to get you the same answer. Okay? So it's going to be 6 times 2 because this is plus and this is plus, so there are 5. This is minus, so I have to divide 3. Which gives me log base 7 of 4, which I can't do in my head. Which means I've got to do log 4 divide log 7. And then use my calculator. And when you do that, you should get approximately 0.7. Okay. The last page only deals with the proofs of what we did today. You don't need to know the proofs, but I like to always include them, rather than just give a formula and say, okay, this is what you do. There is a mathematical reason behind these formulas. Doyan?
This cannot include approximate or whether teachers are.
No. You wouldn't lose anything there. Yeah. For me, that's extremely minor, and I would not be a communication error. Yeah.
On the proposal.
On the provincial as well. Yeah.